Hi all, welcome to my channel Learn with Girish. I'm planning to do a series of sessions on GitOps. Um, so today is my first session wherein we'll look at what is GitOps and some of the benefit GitOps provides. A little bit about myself. My name is Girish Kaudar. I work as a cloud and DevOps architect. I've been certified in Azure and also in Kubernetes. These are my Twitter handle and LinkedIn profile. You can reach me in case you have any questions or clarification. And also I'll be sharing these slides inside the description box. So with that, let's start the session. Okay, let's see what is GitOps. So this is the definition of GitOps. So the highlighted text here is Git as a single source of truth, and another one being the infrastructure and the application deployment. So you can think of GitOps as a new way of doing continuous deployment, wherein your files related to infrastructure and application are stored as part of Git. And we will be having a controller or an agent which will be looking at the files which are stored in the Git or some of the changes that are happening to these files and automatically apply these files or changes to the target environment. Typically, it's a Kubernetes environment, but that's not the case, which we will see shortly. So to better understand GitOps, let's look at a few diagrams over here. So let's look at the first row wherein we see the deployment without GitOps. So in your CI, you will build the containers, and in your deployment, you refer to some of those containers in the deployment.yaml, and you might have many other manifest files. And these files have to be deployed to your Kubernetes cluster, which you might do using kubectl apply directly if it's a small cluster, or if you are using a proper CD pipeline, you might use GitHub Actions or the DevOps task to do the kubectl apply. You might have some customization to your YAML files. So in that case, you will use customize and then do a kubectl apply. Similarly, you might have all your manifest files stored as part of a package. In that case, you would do helm install. So let's look at how we do the deployment with GitOps. So the first two steps, right, the CI part and referring the container in your deployment files will still remain same. And with the deployment part, we will have something called as an agent, a GitOps agent or a controller, which will automatically look for the changes that are happening to your Git repo. And accordingly, it will do all those changes to our target Kubernetes environment. So there are different kinds of mode. Some work in the pull fashion and some tool work in the form of push fashion. So this is how the GitOps helps in doing the deployment. And this is not confined to Kubernetes environment. So we have something called as TF controller agent, which is a new controller which looks at the Terraform scripts which are stored in your Git and apply those Terraform scripts to your AWS or Azure environment. So if you think of how the GitOps agent works, right? So it's similar to what the Kubernetes architecture is. So in Kubernetes, we have controllers, and for these controllers, we give a set of YAML files and ask the Kubernetes to bring the state to this particular desired state, and the controller will go and apply all these changes and bring the cluster to the desired state. And if there is certain drift, right, the controller will take care of bringing back the cluster to the desired state. So for example, it might be like if there is a node failure, it will bring back that node, or if a pod fails, right, it might bring the pod. So the GitOps agent works in the similar fashion. So it will keep on looking at the changes that are happening in your Git repo and accordingly sync those changes to your target list. Let's look at some of the principle of GitOps. The first one being declarative. So the files what we store as part of Git, right, should be declarative, similar to your Kubernetes YAML manifest file or your Terraform files. The second one being versioned and immutable. So since we are storing it in Git, all the files, so those will be versioned and also immutable. You can also configure pull request for your changes in your Git so that the changes in those files are reviewed. The next one being the files are pulled automatically. So as we discussed, right, you need not apply your Kubernetes YAML manifest file by using kubectl apply, or you need not run helm install. The agent should take care of pulling the changes that you are doing to the Git repositories. And the last one being continuously reconciled. So as we discussed, right, so the controller or the agent, right, should continuously monitor for changes in your Git and apply those changes to your target Kubernetes cluster. Now let's look at some of the benefits of GitOps. The first one, the configuration drift. So consider a scenario wherein you have multiple environments and you are facing an issue with one of those. So you or your team member might go and fix that issue specific to that environment, and you might forget to do those changes in the other environments. So this is where the configuration drift occurs. So since as part of GitOps we are storing or tracking everything in Git, we may not face these kind of issues. Next is increased productivity and agility. So consider you have containers created by developers and you need not worry about deploying those containers, as it might be a very small change to a Git. And since developer can iterate faster on their features, it can increase the business agility. And since they are already aware of the Git workflow, it can enhance the developer experience as well. The next one is the better ops. So one thing I did not talk about is not only we can store files related to your deployment in Git, you can also store artifacts which would apply policies to your Kubernetes cluster, which would enhance better ops and also provide better security. The next one is the consistency and reliability. Consider a scenario where you want to create a new environment similar to your existing ones. So you might have to create a Kubernetes cluster, install an GitOps agent and point that agent to your existing Git repo, and you would get a new environment which is consistent as that of your existing ones. And the next one is the rollback and auditing. So since we are storing everything as part of Git, a rollback is very simple. You can do a Git revert and you would go back to a previous version. And auditing is by default feature provided by Git. I believe there are many benefits of GitOps. Let me know what do you think in the comment section. With that, let's look at a demo. Let's take a look at the application. So this is the Azure routing app, which was available in GitHub. So I have taken that and hosted it on Azure at app.githubshost.com. So this is the app where you can do routing on cats and dogs. So let's look at the repo for this application. So this is the repo which I opened it in VS Code. So here, if you see, we have all the files stored with respect to deployment. So let's look at the app deploy. So the application itself is having a backend wherein we are using Redis, and we have a front end as well. And coming to the infra part, we are deploying Cert Manager and Nginx. So if you see these YAML files, this is where we have defined the Helm chart declaratively. So this is for cert manager as well as Nginx. And once we do the infra deployment and the app deployment, then we do some post deploy configuration wherein we generate certificate using cert manager, and then configure the Nginx to point to the front end app. This is the folder structure for our Git repo. So let's look at the Kubernetes cluster. So I have created an AKS Kubernetes cluster in Azure, and if you see here, there is a section called GitOps. This is where we need to do the GitOps configuration. So this configuration will create the GitOps agents, and those agents will look at this particular Git repository and also this master branch, and we can also specify the sync interval over here, and we can also specify the names where all your files should be deployed. Let's take a look at the deployed files. Let me go to the Cloud Shell, and if you see here, if I go to the demo app namespace, you will see all these objects are getting deployed by that GitOps agent. So let's look at some of the deployments. So we have two deployments here, Azure OAuth back and Azure OAuth front. So what we will do is we will break this application by deleting one of the deployments over here. So let me do a kubectl delete and copy this one. So I'll go ahead and delete the front-end deployment. So this is deleted now. So let's look at the deployment again. So if you see here, now we don't have the front-end deployment. So let's navigate to the app here. Now it's giving an error because the Nginx is not able to find the front-end app. So let's wait for some time and see if our front-end deployment will come back, and whether we are able to see this application up and running. So after a few minutes, when I get again the deployments, I see the front end back again. So the GitOps agent has sync all the files from my Git repo, and if we navigate to the application, it should be up and running here. Okay. Let's summarize today's session. So we looked at what is GitOps and some of the benefits of GitOps. In my next session, I will cover in detail on one of the GitOps agent called fluxv2. Thank you for joining the session, and if you have liked the video, subscribe to my channel and stay tuned for more videos like this. Thank you.